Okay, quick repetition. What are we doing here? We're now clustering the servers and we're getting dangerously close to actually clustering them. We're going to distribute the load across multiple servers. We're going to provide backup machine when one goes down, yes. And there we will take some shortcut because we're just simulating and we're only covering Liferay. We'll just have a single load balancer, a single database and so on, but let's discuss everything. On the web tier and the load balancer, you typically have some load balancer in your system, which then directs the traffic to all of your cluster machines. In our case, we will use HAProxy here. If you use HAProxy, Nginx, F5, Apache, or any of the other solutions, any of the cloud native load balancers in whatever cloud provider you use, any of them would be an option for your load balancer. Of course, if you go cloud native, you don't need to take care about distribution and having that fault tolerant because it's load balancer as a service in the end. We can handle load balancing just with the web servers. Just say, if you run Apache anyways, Apache has load balancer modules and it's trivial to configure it as the load balanced module. Then on the application tier, that's today's focus. Typically, I don't care too much about Tomcat, about Wildfly, about all of these application servers, but as we use exactly one application server for every installation of Liferay, we'll need to take care of the application server anyways. This includes Liferay, all of the additional services that we have, and the components that we take care for here are the cache. Every single Liferay installation has its own cache, and when you update some data in one of the servers, you'll definitely want them to be updated in all of the connected servers as well. That's why we take care of the cache. On search, as soon as you upload a document on one of the servers, you want any search on any of the other servers to find these documents as well. So that needs to be taken care of. And we have already seen the document storage, the document library. Any document that you upload to your node number 1 should be downloadable from node number 2. Makes sense? It's just very simple. On the database tier, we just are happy with a single database, single MySQL installation. That's it. In a production system, if you have a high load, you may want to cluster the database as well. If you want failover scenarios, you want to cluster the database as well. Here in this training, we're happy with just a single one. On the clustering side or on the database clustering side, you can have things like read-write database splits. That's what we mention here as well. Write to one database and read from multiple of them. There's the one caveat, anything that Liferay writes into the database should be the same when being read again. So an eventually consistent database might just pollute your cache. If you upload something to server 1 to node number 1, well, if your database cluster updates eventually, like after half a minute, you will serve stale content, and that's not what you expect. So basically what we want is an online database that just works atomically. Today we'll use the single database, and then now we'll get into the policy or the preferences where some people have a different opinion than I have or than we have, because we go into session affinity. What does that mean? Well, if you're running a cluster, then every cluster node handles all kinds of different requests. Let's say we all in this room access a certain URL. Session affinity means everybody who is coming with the same session identifier will always end up on the same node. These requests are not balanced request by request by request, but they are balanced session by session by session. As soon as I start a new session, I get balanced to a certain server, and I'll stay on that server until either I go away, I'll end that session, or the server goes away. As opposed to the sessions being replicated in the whole cluster. Now, we do strongly prefer session affinity, that is sticky sessions, which means you get balanced once and then always directed to the same server. Many times, I'm seeing that on the forums, I'm seeing that with customers, I'm seeing that in all kinds of installation. People want to configure session replication. Because if node 1 goes down, you want to continue the service. Now, yes, that is a good idea in principle, but in practice, it requires that all of your data that you have in your session must be serializable and storable to disk without error. And it implies that this serialization happens every now and then, which means if you have multiple machines, multiple cluster nodes, in order to be able to handle more load, and then you'll serialize all of the session to disk, to database, or elsewhere, you're just throwing away the performance that you just won by doubling the number of nodes. That performance goes steeply down because of the overhead of serializing the session content. So if you cluster for additional load, you probably don't want to have session replication. If you just cluster for failover ability and you have enough reserve in your machines, let's say you're a tiny company or a small company and you run your intranet and there's only a few hundred people concurrently on your server and the server is more or less bored by these requests anyways, then you might want to activate it. I still recommend against it because after all, you'll need to be able to serialize everything, and if anything fails, you will need to debug that failure and fix it. So technically, go with sticky sessions. Sticky sessions apply or are configured on the load balancer level. The load balancer needs to know the names of all of the different machines that are there and will typically, as far as I'm concerned, will typically tag the session identifier cookie or any other cookie or any other aspect of your repeating request with a hint on which server should handle this request. For example, with Tomcat, with the load balancing modules that I know, the information is just tagged to the session identifier so that the load balancer has an easy job inspecting the session identifier to figure out where should it go. And you can check this in our installation. Just check your session identifier cookie and see how it looks like, and it will have some information about the actual node being used. We'll need to make the load balancer aware of all of the nodes so that the load balancer can route that traffic and keep everybody on the same node. And for that, we'll configure the application server to just identify itself to the load balancer by giving a specific name. And now, we can have both. On the Tomcat side, we can configure the name for Tomcat, which might ruin our expectation that we can use the same image on every single node. Or the load balancer can just figure it out through the IP address or any other aspect. Session replication, as we see in this diagram, might be something that really steeply affects your performance when you replicate all of the sessions to all of the other machines. The more machines you have, the more chatter there is in between the machines and your performance will go down. Now, this is not the only solution on session replication. There are implementations where every node just finds one partner node and replicates the sessions to that node. There are implementations where everything gets stored in the database and only retrieved from the database if needed. So you'll just have the write operations, never the read operation until it's actually required. Which of the implementations you have, you figure out. I still recommend against session replication. And if you have session replication, go with sticky sessions anyway. Because if they store the session information in the database, at least you only want to write them and never read them again, because that's something that you can save. You don't need to use that time. As far as I'm concerned, we don't really need the clustering aspects of the application servers, of the Java EE application servers. There are a couple of things where they can help us, but we don't really make full use of them because we'll cover the firewall, the load balancer, that's external. And with all of those reverse proxies, in the end, we'll hit the Java EE servers. But once we are on one server, we actually don't need the application server cluster. However, we'll still need to look at the communication between the web server and the application server. Here we have an example for two protocols between those implementations. HTTP, you probably already know it, I guess so. We can add HTTPS, but as with the whole training here, it will provide you with an encrypted connection, but setup of all of the certificates is a mess. So we don't cover HTTPS in this training because we're running on a local system anyways, and we don't want to deal with the HTTPS with a certificate complexity here. You can also use AJP, which, for example, Tomcat has a connector, and Apache has modjk, has HAProxy AJP. This is a binary protocol that covers almost the same or a little bit more than HTTP. It transfers the actual HTTP request a little bit better to the next level between the reverse proxy and the application server, or Tomcat in that case. I like it better, but it's a binary protocol and you have no chance to encrypt this connection. AJP is purely clear text, but it's binary. I still like it, but if you need encryption, you'll need either a VPN or you'll need HTTPS, period. I've mentioned sticky sessions before, so please configure sticky sessions no matter what. And sticky sessions are handled by the load balancer typically, or in our case, we'll set the stickiness based on the J session ID, and then we'll forward to a server based on the name. Here it says through AJP, and right now I can't remember what we actually configure. I think we configure HTTP balancing. So you will see that in the exercise if our HAProxy forwards in HTTP or in AJP. We got to see. My systems that I set up typically forward through AJP, but I'm setting up Apache on that level. In this exercise, we have HAProxy. I believe it's HTTP. When you deploy applications in a cluster, you'll need to pay attention to one aspect. You have two servers, and they better run the same plugins, the same applications, and everything identical to each other. Because if you deploy your own applications to one server but not to the other, and your portal server attempts to display them, it can't. Well, at least one of these servers can't. So you'll need to pay attention to deploy all of the same applications, preferably in all of the same versions on all of your environments. Make sense? And now the question is, how do you do that? With Docker and with our images, we are on a good way to to really make sure that this happens. If you are running on a classic application server, then you might be aware of the mechanisms that this application server provides to you. Cluster deployment. You'll upload a plugin to one server and it will be distributed. There are master servers for a full cluster where you'll just upload something to the controller and it will distribute to the whole cluster, to every machine. There's one problem. Liferay applications are not distributed as a web application that gets deployed to the application server, but it is an application that gets deployed to Tomcat's own OSGI or to Liferay's own OSGI container that is independent of the application server, which means you must pay attention to Liferay and Liferay's OSGI container, not to your web application server or to your application server as a whole. Which means the cluster operating mode of that server typically doesn't really help you. But as I said, with the setup that we have here, with our Docker images that we create with all of the applications embedded in that server, we're on a safe way. We can just fire up the image, update that image, and use it, fire it up on all of the machines. That's the basics for clustering, the basic aspects, and then during the next chapters we're going to look into what do we actually need for Liferay, what do we need to pay attention for. There is a couple of aspects, kind of a checklist that we'll need to pay attention to, and this is what we're going to discuss in the next chapter. For now, let's just prepare, and in our preparation we are going to configure HAProxy. Oops, there we are. We're going to update the HAProxy configuration so that it is aware of a couple of Liferay servers, that is 2, the number 2, and then we'll have HAProxy ready to serve. In our case, we will still be able to address every single node. We'll be running on port 8081, as we had before with node 1, and then we'll have node 2 on port 8082. But current exercise, very brief, very quick. Go configure HAProxy, and then I'll see you in the next chapter.